I would like to now call to the stage Estonia's preeminent space expert to host our panel. And this would be Paul Liias. Liias is the, you are the technology expert at the Economic Affairs Ministry, Ministry of Communication, correct? And also co-founder at Cubehub.
Yes, that's true.
All right. Stage is yours.
Yeah, thank you. Ministry of Economic Affairs in Estonia is also known for the Estonian Space Ministry, but it's another story. Today is actually a funny day for me because I have been the last 2 hours in civil life, so I just came from a military exercise which lasted for 2 weeks, so it's really difficult to see real people not in green, laughing. Everyone is happy, so it's nice to be here. And I have slept only 2 hours, so I will manage this panel. Today we will speak about NewSpace, so what is NewSpace and what is going on there. And of course, I will not do it alone. We have 3 really good speakers, therefore. But before I invite them to stage, then a short backstory. For me, or even for Estonia, everything started in 2008 when we started to build the first Estonian satellite, S-Cube-1. And back then we had no idea actually what we were doing. Now we understand actually that these CubeSats have started a revolution in the industry. They are changing the space industry, and what's actually going on there, my friends will introduce. At first I will get to the stage Sebastian from Germany, from Interstellar Ventures. So, please. Then just take a seat. Then Scott from Canada, from Helios Wire IOT. And finally, my friend from San Francisco, Ron from Nanoracks. So, please take a seat. So, Sebastian, what are you up to? What's going on in space?
Can everybody hear me? Hi. So first of all, I really want to thank the organizers to organize such a really interesting and awesome event. So I feel really like it's the age of enlightenment in which we are right now in. And just the previous panel was really great to see how Estonia is really moving forward with making the life of entrepreneurs very easy and unleashing this entrepreneurial revolution. And so I'm an entrepreneur by myself, and actually had a company in Berlin for 3.5 years, and decided to 2015, coming back to the conversation about the future of work, to step down from my company, actually sold it to my partner, and to really focus on increasing the quality of life. So I spent really the whole year with really trying to do nothing, in terms of not really work that much and be with my family, with kids. But then suddenly I discovered this exciting new field, which is called NewSpace, and really got hooked, and eventually also a nuclear reactor ignited in myself. And I really started to talk to entrepreneurs, to investors, to space agencies in Europe, and also these big companies like Airbuses and OHBs and Boeings and these big guys. And so what I'm currently up to is, so the last year we spent as a small team to really looking into the whole ecosystem in Europe. So what is really going on in Europe in terms of this whole new space adventure. So really commercializing the final frontier, but also looking then last October over the Atlantic to the US and really trying to understand, so what is going on there? So why does Europe not have a SpaceX or Blue Origin? So why is why is the bunch of billionaires now spending their private money on doing these things which they are doing, and why the heck is NASA supporting this? So really compared these two ecosystems, came back to Europe and what we are currently doing. So we are launching an early stage venture capital fund focused really on this NewSpace Ventures. We are in the fundraising phase, and hopefully we will close the fund until end of this year. So this is what we are doing. And beside that, we are also thinking about it. So how can we really stimulate the ecosystem in Europe? Because the, let's say, the established government-led, let's say, framework is not really enabling entrepreneurs to do really exciting stuff. So we are eventually thinking about launching a Space Entrepreneurship Foundation, but this is still to be defined. Thanks.
So, Scott?
Yeah, thanks. I've been in NewSpace for about 7 years. I'm working on my second space startup, and we'll talk a little bit about that in a few minutes. My previous company was a company called Earthcast. We started it in my basement in Vancouver, and we signed an agreement with the Russian Space Agency to put cameras on the International Space Station. Cameras were expensive. They cost about $30 million. So we ended up raising a couple $100 million, took the company public, scaled it up, and launched the cameras to space a couple years ago. They're now on the International Space Station, 250 employees and so forth. And I stepped down about a year ago to start a new company called Helios Wire, which isn't a imaging from space company, but is building out a space-enabled Internet of Things network, and we'll talk about that in a few minutes.
So, Ron?
Yeah, I'm 26 years old.
Yeah.
I've only been in the space industry all of 2.5 years. So it tells me that this is a new and interesting field, and that we're starting to see a lot of young entrepreneurs coming out of a software background like myself, moving into this industry. So I don't want the word space or cosmos to scare anybody. What space is image analysis, data analysis, software systems, AI, predictive analytics, prescriptive analytics, customers across any number of fields: agriculture, logistics, shipping, forestry, crisis intervention, and of course, military applications. The fascination for me was, coming from software, big data, right? And if we think about space as a big data play, and that's how I began to understand it, it was very attractive for me, a serial entrepreneur with more than one exit, coming into this as, look, I get to start over again. I'm a 26-year-old.
Okay. Yes, you want to use the presentation?
I guess it's yours.
Sure. I can roll first.
Yeah.
You mind if I stand?
Yes.
Yeah, go ahead.
So I told you a little bit about my background in big data and analytics, and really one of the things that pulled me into the industry was being able to use and understand very quickly that space objects or satellites are an extension of the Internet of Things, or maybe even the original Internet of Things. High capability communication satellites, our internet networks, television networks, all communicate through these very large satellites as big as this stage here, costing over $500 million and being launched into space. Something about that size right there on the screen. $500 million, okay? And Paul mentioned CubeSats. People are putting together CubeSats that are about the size of half of a PC into space with optical sensors, batteries, solar panels that may not have the capability of a $500 million satellite, but if you put enough of them up there, let's say 20, and they have a high refresh rate. They circle the Earth in low Earth orbit at 400 kilometers, which is from here to where? Hamburg? that the amount of data that they collect and can communicate back to Earth is being done for under 10 million US dollars investment. So compare the difference, 500 million, 10 million. That massive disruption, and we're just at the beginning of it, presents incredible opportunities for new companies to enter the field. Do you need to put hardware in space? It turns out sometimes you don't. Sometimes you can buy existing streams of data and find different applications. And for me, the focus is always on customers. So I love saying this. One of the things that when somebody asks me what I do, I say, well, I launch products. Last year, I launched about 50. Just in the past 2 days, I launched 10. And this is a deployer spitting out something the size of a loaf of bread into space just last week. These are Earth observation satellites with hyperspectral sensors, simple sensors that you would find on a iPhone camera, communications antennas, and they do all this heavy lifting, and again, at a fraction of the investment that these large satellites, the size of this stage, would cost. So this disruption is here now. We're starting to see more and more opportunities. Who here knows who Elon Musk is? Jeff Bezos? Yeah, these are billionaires. Oh, and let's not forget Richard Branson, right? These are billionaires who understand that the opportunities in space, whether it is delivering people to Mars, giving people a thrill ride up into orbit in zero gravity for a few minutes, that the opportunities exist beyond this planet. So I call it the $3 trillion industry that nobody knows about. The opportunities are out there. It could be something as simple as asteroid harvesting. Not simple by any stretch of the imagination, but it's going to take work and effort to get there, and maybe somebody in this room is the first person to uncover better ways to harvest asteroids. Materials, testing new sensors and capabilities. One of the most interesting things to come out of in-space research, so we use the International Space Station as a primary platform, and I'll wrap it up on this, is we are discovering new molecules that grow in microgravity, and they behave differently than they would here on Earth, and we're discovering drugs that are curing very hard-to-cure diseases by testing them on the International Space Station. So we have a whole library of pharmaceuticals that can now be modeled and tested in a microgravity environment that will provide the cures for tomorrow to disease states that we have today. So there's a range of things that you could participate in the new space economy, but keep in mind, there's a big pool of money out there. I could tell you a little bit about Nanoracks. Again, we use the International Space Station as a primary platform, but really we are about enabling entrepreneurs and existing companies to explore and discover what they can do in space. Thank you.
Thank you, Ron.
Thank you.
Please, Scott.
Yeah, thanks. As I mentioned before, this is my second space startup. The first one was taking pictures of Earth, of course, from space. And this one, we're building out a space-enabled Internet of Things network. And basically what that means is that we have spectrum. And spectrum is the right to send data from Earth to space. It's monitored by the UN. It's hard to get. It's incredibly difficult and rare. And we, in fact, have a ton of it. And so what we're doing is building out little tags. Our model is to build little tags about the size of your cell phone. Solar-powered, stickers, independent. You can attach them to things, and these little tags will beep data to space. Kind of whatever information you want them to beep. Location, elevation, temperature, proximity. You can hook them up to other sensors, industrial, oil and gas, farming, transportation, and they'll just send the data to space. And if you have one satellite, it'll pick up the beep every 12 hours. That's kind of how the orbits work. If you have 2, every 6. If you have 4, every 3. If you have 30, every 5 minutes. And so at Helios, we have enough spectrum to monitor up to 5 billion of these devices. So it's a huge allocation. Where we are right now, I'm based in Vancouver. Our satellites are being built down in San Francisco. The first 2 satellites go up next year. And then over the next 4 or 5 years, we'll launch the rest of the constellation. And think of industries like oil and gas. You can put a tag on a pipeline in Africa, and it'll track vibration or noise. So Nigeria loses about $3 billion of oil every year to pipeline theft. People literally drive up a tanker, stick in a screwdriver into the pipeline, and then leave. And some guy wanders by 3 or 4 days later. There's oil all over the ground. It's a mess. They've lost oil. And so you can put a little sensor on this pipeline. It's in the middle of nowhere. There's no cell phone or Wi-Fi. It's remote. And this sensor will track noise or heat if there's a fire. It'll track vibration if it's vibrating too much, and it just sends it to space. And if there's no problem, there's no problem. If it gets a little too hot, it gets a little loud, someone's backing up a truck or something like that, it'll send this, the data will go to space, goes down to a ground station, goes up to the cloud, and it can trigger someone's phone or something like that saying, we might have an issue at mile number 55. This is what the satellites look like. They're small and they're cheap. They're about the size of your backpack. They cost a couple $1 million, which in space language is cheap. They weigh about 20 kilograms. They're not particularly complicated, actually. There's no real IP in the space segment. It's a box. It's got some solar panels, and it has an antenna. And the device in the ground beeps the data to space. Satellites pick it up, collect it, drop it down, and then it goes to the cloud. And then to the point we just heard, you can use the data to try to predict the future. That's basically what the point of this is you can aggregate all the data together and try to run algorithms and use it to try to predict the future. This is kind of how we view the industry. And I think this is common actually in a lot of industries where people are using NewSpace to try to disrupt it. It's a pyramid, and at the top you have the typical space customers, which are governments and massive corporations. It's people who are happy with products where they've spent $500 million building the CapEx, building the constellation, building the satellites, the type of infrastructure. And then the new space companies, of which we're one, are essentially trying to democratize. If we can take a service or a product that up until now has only been available to governments, the US government, large corporations, and open it up for everybody else, then you have the ability to scale, frankly. And as entrepreneurs, it's the ability to scale. It's incredibly similar to the cable industry in North America. You have 100 channels. They're all kind of garbage. You might watch 2 or 3 channels. And the TV networks, the whole mandate is to try to give you more channels, more stuff you don't really want, so they can charge you more on a monthly basis. Right now it's $100 a month. They give you more shopping and food channels and whatever else, so they can charge you $125, and then more so they can charge you $150 per month. And that's kind of the similar model that a lot of old space companies have, which is we're going to keep giving you more things you don't need. We're going to keep giving you more data, more bandwidth, more infrastructure. And our thesis, my thesis as the entrepreneur, is that the customers don't actually want that. They want a good enough type product, a Netflix, where it's just what I want, and I'll pay you $5, for example, for it. So we think we can track up to 5 billion of these devices for $1 a month. And if we can do that, we can scale. And that's what Helios is. It's one of the new entrants into the satellite IoT industry. We're not the only ones, of course. There's other ones trying to do something similar. We think there's ways that we can differentiate. We think the market is available to grow. The IoT industry, of course, it's trillions. No one really knows how big it is. And then when you kind of break that down, the satellite-enabled part of the IoT is a niche market. It's about $2 billion a year. So it's not huge in terms of industries or markets. It's quite small. And there's 5 companies that generate about $2 billion a year in revenue. It's Iridium, Inmarsat, some companies that the people have heard of. And we think with a product that doesn't cost $500 a year, which is kind of what satellite IoT is, it costs $20 a year. How much of that existing market can we take away, and then how much of that market can we scale? Can we grow to people who don't want to pay that kind of, but are happy with something good enough? And that's kind of how we fit into the NewSpace infrastructure.
Yeah, thank you for the interesting numbers. So, please, Sebastian.
Yeah, sure. Thanks. So what I would like to do right now is to kind of share with you the findings, like a really general overview of the, I would say, next industrial revolution, which is not just taking place here on Earth, but also in space. And so, because you asked me also to provide some more insights and also kind of a framework for also Estonia to think about how it could get engaged and involved in this new space revolution, I would say, and also how to provide kind of a framework for entrepreneurs, because in the end, it's all about a paradigm shift we are talking about. It's not about really the hard technology. I mean, this is still a very, very important component to it. But I guess it's more about thinking of space as a service or space as an innovation platform, and really providing services to customers and not really focusing entirely on the technology. I mean, technology is still very important, but I guess as you look at on the CubeSat development, I would argue this is the first iteration development of new technologies. So people are actually hacking into the space industry by leveraging satellite technology, which is becoming more and more accessible. And therefore, you see this new trends, a new market, which is basically opening. And you mentioned this $3 trillion opportunity. So right now, the space market is around 350 billion yearly. But as the access to space becomes more and more cheaper, obviously the market will grow. And so we talked about e-residency. And I would like also to throw out an idea, or maybe kind of provoke. So this is a concept right now being thrown around by the European Space Agency called the Moon Village. And so eventually, if, for example, Estonia would provide a service for companies being registered on the moon, who would apply for that? So to really register a company on the moon with services which are right now comparable to Estonian e-government. Someone? Okay, not so many people, but I mean, this is really becoming reality. I mean, this is overdue, but right now what we see is really the technological development advancing and also costs coming down. And so there's a race going on, like a space race, between private industry, but also public agencies. And the whole idea of looking into now this new space opportunities are also deriving from the 4th industrial revolution, where really technology is advancing. And what we really clearly see is that the role of governments and also space agencies is now really changing and shifting, because there's new dynamism, and there are new actors, there are new roles. Space agencies need to redefine their role. It's not about spending taxpayer money for these big, huge satellites you've been talking about, like huge multi-million-dollar projects, which are actually paid by us, citizens, and which are really not really efficient. And on the other side, the talk in town about the Industry 4.0, I mean, it's there. So technology is driving changes, new business models, ecosystems, and we learned about also these totally digitized supply chain or value chain, so it's there. And these effects are also influencing how the space sector is right now evolving. And I guess the best description which is out there has been provided by Jeff Bezos, and he sees really space as an innovation platform, and he compares it like to this building up the infrastructure like the internet allowed him to create Amazon. So right now we are really in the heavy lifting of creating this infrastructure, and then eventually on top of that we can build applications. Therefore, this idea of space as a service, or space as an innovation platform, is really something what I guess resonates with most of the entrepreneurs. And what is right now required also to kind of step into this dynamism is a new way how governments and space agencies collaborate with these new entrepreneurs, either being an anchor customer or providing proper frameworks and also ways to collaborate. This slide shows really kind of the evolution where we are potentially heading. So on the left-hand side, you see kind of the traditional way. So it was very closed, very exclusive, traditional. You had all these space agencies getting access to the knowledge, technology, talent, ideas, obviously funding, the infrastructure for developing networks and markets. But right now, you see the shift towards the right, where you see eventually an open, democratized, future-oriented, and self-organized and distributed market, where you see organizations not really relying on the old infrastructure and not only the space agencies playing a role. And I actually, in the spectrum, different initiatives, companies, kind of positions, and this is really moving into more democratized access to space. And obviously also through reusability of rockets, the prices are coming down, and eventually one day it will be really cheap to go into space. So therefore, there are new players, new ambitions, and new horizons opening up. So for example, just yesterday, a New Zealand-based company called Rocket Lab launched from the private launch pad in New Zealand, a privately funded rocket. I mean, how crazy is that? So this is happening, and New Zealand is currently thinking about a legislatory framework, how to enable space entrepreneurs coming to New Zealand and really doing interesting stuff. Because the challenge right now is we have an outer space treaty, which has been signed in the 60s, so it's a long time ago, where we had a total different reality, kind of the Cold War going on, and everybody was worried that Russia or the US might launch nukes from the moon, so they got this sorted out in this treaty. But right now we have entrepreneurs eventually want to do kind of moon activities, commercial moon activities. So countries need to adapt to it. So therefore, New Zealand is really thinking how they can create a proper legal framework. Then we have obviously new players like India coming up. Like a couple of months ago, they launched a world record of over 100 satellites on one rocket. Then we have the UAE talking about Mars City, okay, in 200 years from now, but they are really serious about this. And then obviously you have China, really challenging the world superpower US with all the different activities which they are now doing, and are also serious about this. And just as an example, obviously they are not part of the ISS, the International Space Station, so the US didn't let them in, obviously because of serious reasons, but now they are launching their own space station and inviting other countries to join. So using this type of things as a soft power exercise, and so you see different changes, not just enabled by technology, but also through mindsets and access to these different things. So I talked about hacking into space, and I guess these two companies are a very good example. So the one from Finland is called Rocket Lab, Space Reactor, sorry, and basically it was an exercise where a creative industry, digital industry, saw at the university a great team of engineers doing CubeSat development. I said, hey, look, this is a great idea, we would like to support you. They invested in this team and enabled them to build a satellite. And in the next iteration, they said, okay, what kind of services can be really leveraged and on top of that, and how can the services serve our customer base? So they really went into this thing and realized, okay, actually things can really blow up. So by iteration, they really got into the, let's say, technology and figured things out. And also they had help from ESA, from the European Space Agency, but they, through the lowering of the barrier, they got into the space industry. And another example is a Poland-based company. So they are stock-listed gaming developing company, And they saw eventually this whole CubeSat development as a great way to put really a kind of a sensor network into space. So how they see, so this is how they see satellites. And also to think, okay, how can we leverage this technology for Earth-based services? So really the barrier is lowering, and people not from the industry are starting to enter it. And what was already mentioned is space provides a number of different opportunities to really tap into from like Earth-based industries. For example, the health industry. So how can you do experiments in microgravity? How can you do research, microgravity research? Or, for example, the energy industry. So what kind of new technologies can be developed, space-based technologies. So there are a number of different opportunities for Earth-based industries to actually venture in to space, and also through this technology development, to venture out. So to sum this development up, so the space sector is co-evolving, so the private sector is pushing, but also the public sector is adapting. So mainly from the private sector side of things, private investment, new technologies, new business models, but also new ideas are enabling these entrepreneurs. And from the public sector side of things, there's diversification, there are new players. A lot of them are entering the space. And also what is driving this whole thing is like the regulatory frameworks are now being adapted in different countries. And so this is also driving the adaptation. But also what I want to stretch a little bit and also look into the future, because space is obviously very futuristic. So we have to keep in mind, right now, we are really riding this great wave of technological acceleration. And you just, right now, can't imagine what maybe in 20 years from now will be possible by having all these different technologies, and really will be enabling new business models. And what I want also really to kind of stretch is really to think about space-based technologies like biotechnology, autonomous robotics, quantum computing, artificial intelligence, Internet of Things, and you're working on that, and blockchain. So once these technologies are not just being deployed on Earth, but also in space, then an entirely really new playing field emerges, and then really things can become very interesting. So these trends, technological development trends, and which I mentioned also before, lead up to this orbital economy. And it was already mentioned, asteroid mining, but the main point here is that one industry revolution is now taking place on Earth, but another one, which is starting to emerge also in orbit or in space. So what we already see is companies starting to develop technologies for asteroid mining, or for example for in-space manufacturing. So this is very early stage, but it's already happening, and I guess it will still require kind of 5 years to develop, but this is from the technology cycle, development cycle of things, really short time frame when we compare to the previous period. But it's happening, and people are really seriously thinking about mining lunar regolith or asteroids and near-Earth objects, and also to really establish orbital factories in space. And this is just a snapshot of different new space companies which have been very prominent in the last year. And investors are really happy to invest in this type of ventures, but there still needs to be more de-risking of the technology and more development of the commercial markets. And what I would like also to highlight in this part of the presentation is also how governments are playing now a very enabling role. And for example, the government of Luxembourg, which is also a small country, they very ambitiously took the lead last year and launched a space mining or space resource initiative, which was basically embedded in a cluster of different initiatives which they have been running for a number of years. But they decided really to focus on the space cluster, and out of that came up this Space Resource Initiative, where they basically provided the regulatory framework for entrepreneurs come to Luxembourg, establish their companies, and be sure that everything what they do in space is legally. And it's okay to mine resources and sell it commercially. So America was first, 2015, they created the Space Act, which enabled US companies to do it. But eventually, Luxembourg followed, and they created a number of different initiatives which is supporting this. Then the Space Resource Initiative in Luxembourg is just one initiative which is happening currently globally. So you have, as already mentioned, this UAE Mars City initiative, India Space 2.0, ESA Moon Village, United Kingdom Spaceflight Bill, they are quite serious about that, and New Zealand Space Initiative, and also Finland is also working on a law which will allow Finnish entrepreneurs to do this. What I wanted also briefly to focus on is how NASA enabled commercial space. So there was basically this crew cargo initiative which allowed entrepreneurs to step in and provide services. It was supported by NASA, and out of this came companies like SpaceX, which basically used NASA as an anchor customer. So there's also something happening in Germany, but I have to speed up. In the end, what is happening worldwide is this development where entrepreneurs can really be part of it. And once you connect these entrepreneurs also to the established ecosystems, then you can play really through these innovation clusters, a new type of space innovation, which is focusing then also on the different aspects like lunar habitation, orbital habitation. So what I just wanted to really highlight is there's this silent revolution just starting in space, and I guess it's really right now the time for stepping in and also leveraging the different on-the-shelf technologies to start being involved in this field. Thanks a lot.
Okay, thank you. Thank you all for these presentations, and I have so many questions actually that I think we don't have even that much time. But the first thing where I would like to start is that what is, in your opinion, what has been the main change in the regulation or technology which has enabled this kind of new space revolution, and what do you see, how has the sector changed in the past 10 or 2 years, or in the past 2 weeks? So
I'm happy to jump in here.
Yeah.
For me, it is just merely an extension of Moore's law, that the ability to process greater and more information and the shrinking of technologies to where capabilities can now be shoved into something the size of a loaf of bread has really created the shift, because the cost of putting a kilogram in space, let's say $80,000, $90,000, $100,000 per kilogram, is expensive when something weighs more than 5 cars. And now you're sending something up that weighs the equivalent of 5 loaves of bread.
you mentioned in your presentation that you are launching products. What has been your favorite?
I have no favorites.
All of them,
all of them are exciting. Ship tracking, weather tracking, but really all these things, the hardware is interesting. What people are finding to do with it they're just starting to blow my mind. Okay. It's really interesting.
Yeah, no, I mean, I agree with Ron. The cost of getting something into space is kind of the same as it was 20 years ago. It's just that everything is much smaller, and so you can do more. It allows people who are hacking stuff in their backyard to make things, and it doesn't cost 20 million. It might cost 200,000 to launch something into space. So it's not. So the cost of getting something, it's the same math in terms of launch costs. Just the mass of everything you're sending is much less, and therefore it's actually just much cheaper. So that's on one hand. And then on the other hand, I think what's driving some change is just the whole concept of big data. Things in space generate data. That's kind of the point of it, or that's one of the points of it. Whether it's imaging cameras or any kind of other sensor, it generates data. And so being able to use that data in a practical way is also driving lots of change within the industry, even for companies that actually have no ambition to send anything to space, but just want to use other data streams on the ground for some practical purpose.
So what is also driving, I guess, the whole development is private capital, which is more and more being deployed into the sector. As just described previously, it was mainly government-funded exercises, which were very huge and inefficient. And right now we see more and more private investors looking into the space as a great opportunity to really be involved in a kind of next internet revolution type of thing. And the other thing is the use of off-the-shelf components. So again, previously all the different components needed to be tested like 10 times or something, so therefore the price tags were really high for that. So right now people are also starting to use really off-the-shelf components for creating the structures.
I think just on that financing point, it is true that space now is, there's an appetite among investors for space, but at the end of the day, all space does is it, in some cases, gets you into the door. Some investors are frankly space geeks. They grew up looking at the space, and Elon Musk is a great example. The whole ambition is to get to Mars. But at the end of the day, from an investment standpoint, the math still has to add up. So it's not technology, it's not innovation, it's what is the economics of the business case. And if you don't have that in your venture, you won't raise a penny. You just won't. So being part of the NewSpace movement gets you into some space VCs. There are VCs, of course, that are solely focused on space, and then there's lots of other VCs that just use space as a component. But if there's no economics to it, you won't raise a cent.
Can I draw a fine point on that? And it is this, right? I'm based in Silicon Valley. I watch angel investors put together enough money. I've seen crowd-funded satellite projects, right, for less than $100,000. The angel community is the beginning of the food chain. And now we're seeing more advanced investors, private equity. And now we've also seen some exits out of the space industry, Climate Corporation, if you want to consider that one. I keep forgetting who got acquired by Google. Skybox. And so we're starting to see things pull through, and if there's pull at the other end of the investment community, right, hopefully somebody goes public soon. I have a few ideas who that might be, right? Earthcast was one. There will be more. This creates the pull, and then it pulls the early stage investors in that direction, and it is a complete chain. And as we see that increase and accelerate, now's a good time to get in.
If we speak about NewSpace, then we normally speak about some huge names. I mean, Planet Labs, Earthcast, of course, SpaceX, etc. But what's the main reason that there aren't coming that many new startups, or what's the main problem for new founders sitting here who want to start a new space business? What do you think? Where should they focus, or is the technology the main problem, or?
I have a very clear answer for me. It's as simple as big corporations don't see this as something viable or applicable. But you need analysts to come in and say, well, we need to process a data set, right? Detecting leaks in pipes, finding new applications. We need people whose minds are in commercial development, in business analytics, to take a look at business problems first. Small ones, larger ones, and by starting at that as the inception, instead of the fascination with going to space and building hardware, which a lot of venture capitalists will turn away. We don't want to be in the hardware business. But you tell us you have a customer who is ready to pay, and so I've got a handful of customers putting up CubeSats who've already developed customers who are willing to even prepay and help fund their growth. So just need to change the thinking a little bit in order to penetrate the markets, and they are there. Everything from the mom and pop store down the street who relies on logistics to the large agricultural and oil concerns will find ways to apply and use space-derived data. They just don't know what yet.
Right. Totally agree with that. So we helped to broker a joint partnership between a satellite manufacturing company from Berlin and an energy company in Germany, where we really started from a business case. Talk to the energy company. So what are your top 3 business or technological issues which you are currently facing? And then we learned about that, and then we really tried to understand what kind of technology can we apply to solve this issue, to solve this business issue. And then reached out to a number of different companies, space companies who are doing space infrastructures, and then eventually found one who is building hyperspectral imaging sensors. And then through this information, we saw, okay, this energy company has an issue with methane leaks in the infrastructure. And then applied this, and out of this, created a business case. So really, it's starting with a customer and with a business issue or with a business challenge which they have. And this is, I guess, the easiest way to get into this new space industry.
Yeah, Scott, you are the real NewSpace founder here. You have founded already 2 NewSpace companies, basically. Do you call them space companies, or are they more software development companies?
Yeah. So it's a fair question. Earthcast was one of the pioneers of the new space industry, or one of the early stage ones anyways. And it was a successful company. There's still 250 employees there. It's doing about 50 million a year in revenue. It's a good space story for sure. It's not a startup anymore. Clearly, it's not a startup, but it's a good space story. I think people view space differently. Some people think of space as, if we can get to space, we can go further. So if we get to the moon, back to the moon, we can go to Mars. If we get to Mars, we can go further. And it's all about exploration. Other people view space, and this is kind of how I view it, is if we can get to space, we can try to solve problems here on Earth. And so these are, there's 2 different philosophies. And I think it is a space company. It's, you're using software. It is a hardware company. We are a hardware company. But there's no at Helios, I don't think we have any innovation, frankly, on the space segment. The satellites are simple, for all intents and purposes. The little devices that are transmitting data are not particularly complicated. It's using off-the-shelf kind of stuff. There's some engineering, but that's about it. It comes down to, frankly, execution. And it doesn't matter whether you're a hardware, software, SaaS, whatever it is, it's can you execute as a business to take advantage of an opportunity. And so there's some regulatory stuff, there's some innovation, there's, it's can you sell? Can you satisfy a customer? Because if you can, then it's a business. And then investors will fund it. If you can tell the story the right way, investors will fund it. And if you can't, it's an engineering project.
Okay. Yeah, you all also mentioned this deep space stories, especially Sebastian is, I know, really fascinating about the deep space industries. I mean, not the company, but in general. And the question here is that if I hear what Bessemer Ventures and these huge venture funds are speaking about, then they are expecting that if they invest in such a company, then they expect that there will be exit in the next 2 to 5 years. How can these companies survive? Because there will be no revenue even in the next 10 years. I mean, real revenue.
I guess making an exit in 2 to 3 years out of these companies is very bold. So I wish luck with that. But so what we see with especially these space resource companies like Planetary Resources and also Deep Space Industries, they are very much pivoting their business model, and basically what Planetary Resources did. So they turned the camera around. So in the beginning it was okay, how we are going to prospect asteroids, but then eventually they figured out, okay, we have to do some business before that, and right now the main incomes is coming from Earth observation, satellite imaging, and providing this data to customers from AgTech, for example, and really also developing further the technology. And this is also something what Deep Space Industry is doing. So they are trying to become basically a manufacturer, satellite manufacturer for others, and kind of trying to close the business case for them and trying to still achieve this long-term vision. But it's still, I would say, 5 years from now to really see a technology which is ready to go to asteroid, to prospect, to harvest. It's really a long-term play. And eventually, entrepreneurs have to figure out how to tap into Earth-based markets like Planetary Resources is doing right now. So I guess maybe these ideas come from new sources of revenues for these companies when investors talk like this. But I don't think that you will make an exit in deep space or from deep space industries, particular in 3 or 4 years from now.
Is building satellites a business? Just, I mean, hardware.
I think it's part of the integrated food chain. Somebody needs to build them. Right, have specialty manufacturers. GomSpace is in Denmark, Clyde Space is in the UK, right? And there are Japanese companies that are increasingly entering the market. The demand is high. In low Earth orbit, CubeSats deorbit and burn up in the atmosphere within about a year's time. It's a beautiful disposables business.
Okay. Yes, I have here an interesting blue box. What should I do with that? Questions. Questions? Okay. Whoops.
Hi everyone, thank you so much for the insights to the NewSpace businesses. So what kind of advice would you give to all the NewSpace entrepreneurs?
Yeah, mine is simple. Go find a business that you like or an industry that you like and start asking good questions around logistics, weather, things that might affect that business in different ways. And that would start to develop the business case, as Scott and Sebastian point out.
Yeah, I think you find a problem you can solve, and don't make it too hard. Asteroid mining is incredibly hard. It costs $1 billion.
Yeah.
Don't plan to go to Mars. That costs billions. But try to find a problem that you can solve, either software or with other people's data, and a problem that actually has a solution. That does something that people want. Counting cars in a parking lot. You can use that to count cars in Walmart's parking lot to predict revenue of Walmart, and you can sell that data to hedge funds. People want that. Take pictures of oil fields because they can measure the temperature, that type of thing. So find a customer, give them a solution, and don't make it too hard.
Yeah.
Yeah, maybe very quickly. So if you want really to get very quickly into this field, so attend some hackathons, or maybe look up the NASA Space App Challenge, what people have been thinking about, really kind of developing very fast, agile products. There are a number of different initiatives currently in Europe popping up, and I would suggest to attend one of those, and also to link up with the community. It's always good to be connected to these other space entrepreneurs.
Okay, I will.
All right, so thank you for the great conversation. I'm Kimmo Pentikäinen from Elisa Corporation. We've been in communication business for over 100 years, right? And again, things are changing. And I really liked what you said, Ronald, that it's just the extension of Moore's law. Another area of digitalization, what is happening here. But I think also it was great that you said, Scott, that you had to have real tangible problems, the business cases. Now, if there is a Moore's law and there is a business cases, usually it ends up like Swedish band been saying that winner takes it all. So is that the case also with the space, that there will be only 1 or 2 left at the end, if they are business cases and truly being a business? What do you say about that?
Yeah, I don't think space has lots of different industries, of course. And if you look at Earth observation, there's 5 or 6 companies that kind of define the new space Earth observation. EarthCast being one, Planet being another one, Skybox was was bought by Google, is a third. The other ones in the mix, but then it also spread out from there. It's not only optical, but then they went into radar. You can see through clouds at night underground, and then next from there it's going to go to hyperspectral, which is, you can take a picture of a car on the ground and determine if the paint on the car is from India or from Germany, and then just more and more evolution that way in terms of the data that you can get. So, there's a few, and then it just spreads out from there. I think when you start to look at space, it's like any other industry. There's room for lots of different players, and they all just kind of find a niche.
Yeah, we have to end here, sorry. You can have a later conversation with them, but one final question to answer with 1 or 2 sentences only. So where is the future of new space? So what will happen the next?
Yeah, I think 3D printing in space. That's being able to print satellites in space that then kind of generate themselves. So you just print up so you send up the raw material, or you get raw material from other places, and then you build satellites in space that don't need to be launched. And so that's next future kind of stuff. But that is the once we can solve that, and we haven't really yet, but once we can solve that, then we can start to live in space.
Yeah, by extension, in-space manufacturing, and whether that is materials, chemical products, building new space structures, right? Building a new building a new space station. All of these things are part of the developing the economy, pharmaceuticals in space, many things to be done.
Yeah, I totally agree with that, but also thinking about the cislunar space, and I think there's a great initiative right now going on by ULA, so Google this up, Cislunar 1000. So I'm a strong believer that through 3D printing, in-space manufacturing, and all those different technologies now coming online, you are actually creating a totally new marketplace where you can, through the fast iteration cycles of technology, really do amazing stuff which we haven't thought about yet. And the other project which I really recommend to look up is the Archinaut from Made in Space. So this is a really revolutionary technology. This technology will enable what you just mentioned, really to create the structures in space and to manufacture these satellites in space. So this is really opening up really the final frontier for business.
Yeah. Thank you for the panelists. And space and digitalization will be one of the main topics of the Estonian EU presidency in the next second half of 2017. And in November, we will have a huge event in Estonia. It will be the European Space Week from the 3rd until the 9th of November. And during this week, basically, the whole European space, I mean, everyone who is doing something in Europe, at least, hopefully also from the States, is coming to Estonia, to Tallinn and Tartu. So there will be hackathons, there will be startup events, there will be political, a lot, of course, political events, and also events for the industry. So everyone from ESA to European Commission and also many startups have already confirmed that they will be here. So space is the keyword for 2017 in Estonia. So thank you for coming to Estonia. Pauline is not that far away, but thank you especially for Scott and Ron coming all the way from other end of the world. So, and yeah, thanks for listening. And
Thank you.
It's the other end of the universe.
Really.